What if I told you that building powerful AI applications today is easier than learning to code was 10 years ago? And what if I told you that there's an entirely new field called AI engineering that's growing faster than any other tech discipline in history? I'm talking about a field where junior engineers are building applications that handle millions of users, where a weekend project can turn into a unicorn startup, and where the barrier to entry is so low that you don't even need to understand calculus or linear algebra to get started. In fact, 4 AI engineering tools, AutoGPT, Stable Diffusion, WebUI, LangChain, and Olama gained more GitHub stars than Bitcoin in just 2 years. Today, we are going deep into Chapter 1 of Chip Huyen's groundbreaking book, AI Engineering Building Applications with Foundation Models. Chip isn't just any author. She's worked at Netflix, Nvidia, taught at Stanford, and her previous book is an Amazon bestseller. What she reveals about AI engineering will completely change how you think about building software. But here's the thing, if you don't understand what AI engineering is and how it's different from traditional programming, you might miss the biggest opportunity in tech since the internet. The world is moving fast, and those who don't adapt will be left behind. So let's break it down and get you ready for this revolution. To understand AI engineering, we need to start with one word that describes AI after 2020: scale. The AI models behind ChatGPT, Google's Gemini, and Midjourney are consuming a significant portion of the world's electricity, and we're literally at risk of running out of publicly available internet data to train them. But here's the fascinating backstory most people don't know. The statistical nature of languages was discovered centuries ago. In 1905, Sherlock Holmes used simple statistical information to decode mysterious stick figures. Since E is the most common letter in English, the most common figure must be E. During World War II, Claude Shannon used more sophisticated statistics to decipher enemy messages. His 1951 paper on modeling English introduced concepts like entropy that we still use today. This scaling up has two major consequences that created the perfect storm for AI engineering. First, AI models became incredibly powerful, capable of writing code, creating images, translating languages, and solving problems we never thought AI could handle. We're talking about models with hundreds of billions of parameters that can perform thousands of different tasks. Second, and this is the game changer, training these massive models requires resources that only a handful of organizations can afford. We're talking about Google, Meta, Microsoft, Baidu, Tencent, and well-funded startups like OpenAI and Anthropic. This led to what Chip calls model as a service, where these powerful models are made available through simple API calls. Think about it. Instead of needing millions of dollars and a team of PhD researchers to build an AI model, you can now access GPT-4 or Claude with a single API call. The demand for AI applications exploded, while the barrier to entry crashed. That's exactly how AI engineering emerged as one of the fastest growing engineering disciplines in history. Now, let's get technical for a moment because understanding tokenization is crucial for any AI engineer. The basic unit of any language model is a token, not a word, not a character, but something in between. For example, GPT-4 breaks the phrase, "I can't wait to build AI applications" into 9 tokens. Notice how can't becomes 2 tokens, can and it. Here's why this matters for your applications. An average token is approximately 3/4 the length of a word, so 100 tokens equal about 75 words. Different models have different vocabulary sizes. Mistral 8x7b has 32,000 tokens, while GPT-4 has over 100,000. This affects everything from efficiency to cost. Understanding tokenization helps you optimize your prompts and control your expenses. There are two main types of language models you need to understand. Autoregressive models like GPT predict the next token using only previous tokens. They are completion machines, perfect for generation. Masked models like BERT can use context from both before and after to fill in blanks. They are better for understanding tasks like sentiment analysis. But here's the breakthrough that made everything possible: self-supervision. Unlike traditional AI that needed expensive labeled data, language models can learn from raw text. The sentence, "I love street food," automatically creates 6 training samples. Each word becomes both input and target. This solved the data labeling bottleneck that plagued AI for decades. To put this in perspective, if it costs 5 cents to label one image, you'd need 50,000 for a million images like ImageNet. For complex tasks like medical diagnosis, costs become astronomical. Self-supervision eliminated this barrier entirely, allowing models to learn from the vast amounts of text naturally available on the internet. The next breakthrough was expanding beyond just text. While language models are powerful, humans perceive the world through vision, hearing, and touch. So models evolved to handle multiple data types, what we now call foundation models. This multimodal approach makes AI much more powerful and useful for real-world applications. OpenAI's SailIP model is a perfect example of this evolution. Instead of manually labeling images, they found 400 million image-text pairs that naturally occurred on the internet. This was 400 times larger than ImageNet, achieved without any manual labeling cost. This natural supervision approach revolutionized how we think about training AI systems. Foundation models mark the transition from task-specific to general-purpose AI. Previously, a sentiment analysis model couldn't do translation. Now, one model can handle both, and hundreds of other tasks shown in benchmarks like supernatural instructions. This generalization is what makes AI engineering so powerful and versatile. The term large language model isn't really scientific because large keeps changing. When GPT-1 launched in 2018 with LN17 million parameters, that was huge. GPT-2's 1.5 billion parameters made LN17 million seem tiny. Today, models with 100 billion parameters are considered large. But why do larger models need more data? Because they have more capacity to learn, and you need more training data to maximize their performance. Chip identifies 3 factors that created ideal conditions for AI engineering's explosive growth. Understanding these factors is crucial because they explain why we are seeing this revolution now and why it's sustainable. Factor 1. General purpose AI capabilities. Since AI can now write as well as humans, it can automate every task requiring communication, which is pretty much everything. Factor 2. Massive investment increases. Goldman Sachs estimates AI investment could reach 100 billion in the US and 200 billion globally by 2025. That's serious money flowing into this space. Here's a stunning statistic that shows how seriously businesses are taking AI. 1 in 3 S&P 500 companies mentioned AI in their Q2 2023 earnings calls, 3 times more than the previous year. And those companies saw their stock prices increase 4.6% compared to just 2.4% for companies that didn't mention AI. The market is rewarding AI adoption. Factor 3. Low entry barriers. A LinkedIn survey shows professionals adding terms like generative AI and prompt engineering to their profiles increased 75% each month in 2023. The model as a service approach means anyone can build AI applications without massive infrastructure. The democratization of AI is real and happening fast. The proof is in the adoption numbers. 4 AI engineering tools, AutoGPT, Stable Diffusion, WebUI, LangChain, and Ollama gained more GitHub stars than Bitcoin in just 2 years. They're on track to surpass even React and Vue in popularity. This isn't just hype, it's genuine adoption by developers worldwide. Let's dive into the hottest use cases, starting with coding. GitHub Copilot hit 100 million revenue in 2 years. Magic raised 3 million. Anysphere raised 60 million. But here's what's really interesting. McKinsey found AI helps developers be twice as productive for documentation and 25-50% more productive for code generation, but minimal improvement for highly complex tasks. The sweet spot is automating the boring stuff. For creative work, the numbers are staggering. Midjourney generated 200 million in revenue at just 18 months old. Half of the top 10 design apps on the App Store now have AI in their names. The probabilistic nature of AI makes it perfect for creative tasks where there are multiple valid solutions and where creativity and variation are valued. Writing assistance is everywhere for good reason. MIT researched 453 college-educated professionals and found ChatGPT reduced writing time by 40% and improved quality by 18%. Those exposed to ChatGPT were twice as likely to use it in their real jobs weeks later. This shows both immediate value and sticky adoption. Education is being completely transformed, sometimes destructively. Khan Academy now offers AI tutors for personalized learning. But some companies are losing big. Chegg stock crashed from $28 when ChatGPT launched to just $2 in September 2024, as students turned to AI for homework help instead of paying for Chegg's services. Duolingo provides a perfect example of AI's educational potential. They found AI can help throughout course creation, but it's most powerful in personalization. AI can adapt materials for auditory learners, include more animals for animal lovers, or translate math equations into code for programmers. This level of personalization was impossible before. For enterprises, there's a clear pattern. Companies deploy internal-facing applications faster than external-facing ones. They are building AI expertise while minimizing risks around data privacy and potential failures. Internal knowledge management systems and employee productivity tools lead the way, while customer-facing chatbots follow more cautiously. Before building any AI application, you need to understand why you're building it. Chip outlines 3 risk levels that drive AI adoption. First, existential threats. If competitors with AI can make you obsolete. Gartner found 7% of executives cited business continuity as their AI motivation. This is do-or-die territory where AI adoption isn't optional. Apple provides an excellent framework for understanding AI's role in products. Is AI critical or complementary? Face ID needs AI to work, but Gmail works fine without Smart Compose. Is it reactive or proactive? Chatbots respond to requests, but traffic alerts appear opportunistically. These distinctions affect quality requirements and user expectations. Microsoft's Crawl Walk Run framework is brilliant for gradual AI automation. Crawl means human involvement is mandatory. AI suggests responses that humans must review. Walk means AI can interact with internal employees directly. Run means increased automation with external users. You evolve to these stages as AI quality improves and trust builds. Here's the brutal truth about AI development that most people don't warn you about. The 80-I-20 rule applies hard. As one research paper noted, the journey from 0 to 60 is easy, whereas progressing from 60 to 100 becomes exceedingly challenging. LinkedIn took 1 month to achieve 80% of their desired experience, but 4 more months to surpass 95%. That final 20% often requires equal effort to the first 80%. For defensibility, there are 3 competitive advantages. In AI, technology, data, and distribution. With foundation models, core technologies become similar across companies. Distribution likely belongs to big tech companies. But data can be your moat if you get to market first and create a feedback loop where usage improves your product, making it harder for competitors to catch up. The AI engineering stack has 3 layers, and understanding this is crucial for your career planning. Application development focuses on prompts, user interfaces, and evaluation. This is where most of the action happens. Model development handles fine-tuning, dataset engineering, and optimization. Infrastructure manages serving, compute, and monitoring. Most AI engineers start at the top and work down as needed. Chip analyzed 920 AI repositories, with 500 plus GitHub stars to understand the ecosystem. The data shows explosive growth in applications and application development tools in 2023, while infrastructure grew more slowly. This makes sense. The core infrastructure needs haven't changed dramatically. It's the application layer where innovation is happening fastest. AI engineering differs from traditional ML in three key ways that change everything. First, you adapt existing models. Instead of training from scratch, you're customizing, not creating. Second, you work with bigger models, requiring massive compute, optimization becomes critical. Third, you handle open-ended outputs that are harder to evaluate but infinitely more flexible. Let's clarify confusing terminology that trips up many newcomers. Pre-training means training from scratch. For InstructGPT, this consumed 98% of compute resources. Post-training continues after pre-training, usually by model developers like OpenAI. Fine-tuning is what application developers do to adapt models to their specific needs. Understanding these distinctions helps you plan resources and timelines. The workflow has fundamentally changed from traditional ML. Previously, you gathered data and trained models first, then build products. With foundation models, you can start with the product, validate with users, then invest in data and custom models only if needed. This product first approach rewards those who can iterate fast and get user feedback quickly. The future is incredibly bright but moves at breakneck speed. Model inference costs are dropping rapidly while performance improves. The chart showing MMLU benchmark progress from 2002 to 2024 is mind-blowing. We are getting better models at lower costs constantly. This trend shows no signs of slowing down. But there are serious challenges ahead that smart AI engineers prepare for. Regulations are evolving rapidly. Compute availability can change overnight due to new laws. IP rights around AI-generated content remain unclear. Some game studios won't use AI for fear of losing their intellectual property later. Europe's GDPR costs businesses $9 billion to become compliant. The next wave is already coming. Multimodal AI that seamlessly handles text, images, audio, and video together. AI agents that can plan, use tools, and complete complex workflows autonomously. The applications we'll see in the next 2 years will make today's ChatGPT look primitive. The question isn't whether this technology will transform everything, it's whether you'll be ready to ride the wave. AI engineering represents the biggest opportunity in tech since the smartphone revolution. The barriers are lower than ever, demand is exploding, and we're just getting started. Whether you're a seasoned developer, product manager, or completely new to tech, there's a path for you in this field. Here's your action plan. First, grab Chip Huyen's book. It's the most read book on O'Reilly's platform for good reason. Second, start experimenting with AI tools today. Build something, anything, just to get your hands dirty. Third, join the AI engineering community and build in public. The community is incredibly supportive and collaborative.